This program demonstrates how to declare arrays in 3 different ways, so we'll go through those in just a minute. It is a program that keeps a running total of the values in the array, and it uses a loop to do that. So there's a couple different things that go on in this sample. The first way to declare your array is much like you would variables. So it's a dot word, and then you would just give the value, and in a list type format. The next way is to allocate space. So in this case here, I'm using dot space, and I'm saying 16, so you know that a dot word is 4 bytes, so 16 divided by 4 allows you to store 4 integers. And I have that in the comment section here. Then the third way is to declare an array that stores words, and in this case it's storing 3 integers initialized to the value of 100. So again, I explained that in the comments here. So here preload the values, here allocate space, here initialize. So if we start looking at the dot text, the statements, you'll see that here, even though I showed you the 3 different ways to declare an array, I'm using array 1. So my array 1 has the 3 preloaded values. They are loaded into memory. I've asked you to keep a running total of those values. So in order to do that, we'll need to move them to registers before we can perform any add instructions. So first step is to initialize my array position. So T0 is going to keep track of my position in memory. Again, we're moving by 4 bytes at a time. I'm going to load the base address for the array into A0, and then I'm going to jump to a function. So we're passing the address to the function. So go over to the function here. And the first thing I'm doing is the value in length is 3. But that's because I have 3 items in my array. I'm loading that into T6. So I'm going to use T6, the value 3, to keep track of how many times I'm looping. I'm going to be comparing the value of T7, that's my counter, with the value of T6. Also initializing S0 to 0 because that's going to be our running total. So here's our loop. So I do my compare of my counter to 3. If they're equal to one another, I want to end my loop and jump return back to main. Right? So here I'm loading the value from the array at the 0 disposition, because T0 is 0 right now, into S1, and this is my running total. Right? I'm adding S1 to the value in S0 right now, which is 0. And that value is going into S0. So right now I'm adding that 4. Here is where I move my array position over by 4 bytes. So T0, remember, if you think of the array as just like a list of numbers, right? We're moving its position now over by 4 bytes so we can read the next number. Here I'm adding 1 to my counter, loop up back to the top, etc., etc. So that when you're done, S0 holds the running total, so that's the total sum. T0 holds the number of bytes that we've moved over in the array. Return back to main. So we'll pick up here and display the sum of the array values and then end your program.